Hello everyone. I guess I am live. Let me check it once. Yes, we are live. Hello, hello everyone. I guess I am live. Let me check it once. Yes, we are live. Once. Yes, we are live. Okay, let's do this. Today our topic is we'll continue. You'll not continue. We're starting with DP on sequences and then DP on strings, DP on stocks, and then LIS, and then we will go to stacks and queues. This is our target today. I hope we will complete it. We'll try to complete it. Definitely we'll try. Okay. Okay, let's do this. Subset sum equal to the target or not? Yeah, so easy, man. So easy. What will take? Node-wise. Okay. Choose node-wise. 1 second. Let me set up my tab. Okay, let's go. I hope I'm visible. Okay, let me write down the question. Okay, let's 3, 34, 4, 12 and 5 and 2. We need sum equal to 9. That's it. In this I have to revise so many concepts. That's why we'll go in very fast mode. Okay, not like thinking everything. It's like we all know. Basically everyone, so many people start from the first also, like picking this and moving this index or moving this index or moving this index like that. But what I will do is my approach, like I followed Striver for the DP, so that my approach was choosing this one from the lowest to bottom, so that what happens was it becomes very easy for us to write the like tabulation. Yeah, tabulation form. Okay, Striver is the perfect playlist for the DP programming. Yeah, if you are a beginner, if you are watching my video, then you can leave this video right away and go and watch the Striver. It's the better. No one can beat Striver in this topic. Yeah, definitely. Okay, let's move. What's basically we are doing, like we need sum, right? Sum equal to 9. What do you want? What do you have to return? We have to return whether there is an subset. Subset means any values. Determine if there is a subset is equal to sum or not. You all know the subset means, right? Subsequence means the elements has to be in order. Subset means it can be any order. It can be any 3 elements, right? Any number of elements that can form the sum 9. Okay, it's easy. Like what I will do, not this one. For every number has 2 options, right? Pick, not pick, pick, not pick, like this. Pick, not pick, like this. What I will do, like what's the base case? Whenever I returns index equal to 0, from this index to index equal to 0, what I will return? I will return with a value. Array of 0 returns. We have to return array of 0. Okay. To pick, let's say we'll carry sum in the function, so that not index equal to 0 and also another base condition. What if sum equal to 0? Let's carry on sum ind sum and arr. These are the arrays we carry, right? What if sum becomes 0? Like by picking these and these and this, the sum will become 0. Oh, what will you return? Directly return true. There's nothing to hide or something, right? Like we can return true, right? That's what only we want. Okay, then what we will do? Like let's say let's pick it. Let's not pick, so that let me first write not pick. What you will do? For index, should it move anywhere? For no, not pick. Not pick, bro. Yeah, move the index. Not picking means why are you? What will you do staying there? Here also. And sum become sum. Does it change? No. Array is always same. Okay. Write the base condition. If you pick, the number should be less than. Array of index must to be less than the sum or equal to sum. Got it? Then only you can pick. You can write in pick equal to something like initialize it some value. Initialize it some value so that you can, after this you can write this fun of these two are boolean, right? Boolean. Let's return boolean is equal to, let's make it false only. Yeah, initially it has to be false, right? Index minus 1 and also sum minus arr of ind comma arr. That's it. We have to return math dot sorry we have to return something pick or not pick. I hope I don't need to explain this. What is happening? First it will check for the 2 from 2 index, like let's say 2 is index is 1 2 3 4 5 6 index, right? From 6 I will move to 4 by not picking. The sum remains 9 only. I will move to 5 by picking it. How much the value? 7. From this index I will move to the previous index by not picking, by picking, by not picking, by picking, by not picking, like that. It goes. We are covering one pick case for everything and non-pick case for every node. That's it. So that if this can return true, so that from the non-pick of this case can return true, right? Yeah, got it. That's the base case you can do. Why if index equal to 0 return? Let's return false. How not return false? Like the required sum is equal to array of 0 or not. Check. Check the required sum is array of 0 or array of 0 is equal to or not. And that's it. More than that, there's nothing else. We don't code this thing. Give me a second so that I can show you the code. This is the code that we talked about. Everything same. We can use dp. I know you guys know how to use dp. Arrays.fill dp. Here 2d dp you have to use because The changing indexes are two. One is index and another one is sum. Always maintain the one extra size. I hope you get it. Okay. I hope you get it. Yes. Instead of taking an boolean DP, and these things are so much rough. These things are so much confusing. So that what you will take is take int DP only. What we will do is store 1 if it is true. If it is false, store 0. That's it. If pick or not pick someone becomes true, then store this. Else store this. Got it? I got it. What about the tabulation here? Okay. Let's write a tabulation. There is a driver secret that we can write here. Let's remove this. What's the base case here? Let me try. Let's check when I submitted this code. It's all. Whose account is this? 2025. Okay, this year. Okay. I thought it became 1 year. I don't even remember that I solved this question in this year. Okay. Next. Not bad. Okay. How we can solve this? Let's write a base condition. Whenever the index equal to 0, whatever the target it is, doesn't matter. If index equal to 0, area of 0 is equal to target. I don't get it, man. For target equal to 0, for every index you have to make 0, right? Int I equal to 0. For this, writing like this means I'm not good at tabulation, but let's try. How you can it's better to take a boolean array or something like that here in this case. Okay, let's do this. Okay, let's see in the middle how it went. For target equal to 0, arr.len I++ dp of target equal to 0, dp of I target equal to 0 is equal to true, right? Let's assign it 1. And also if index equal to 0, return array of 0 equal to target. Array of 0 is equal to 1, I guess. This is the case. Let's check with the ChatGPT after this. I hope this is the base conditions. Okay. Now what? Just you are going from the top down approach, right? You are done with an index 0. I have to start from an IND equal to 1, and also IND should be less than or equal to arr.length IND plus. This is the condition, and target is like you have to write double for loop, right? Because in sum equal to is covered, right? Where sum is less than or equal to the target, right? I hope it will correct. I am trying. Sum plus plus. I hope this will be correct. I mean, let me try this. Copy these things. Control C, Control V. DP of IND. I mean, I'm a little much confused with this boolean thing, but not that much. It's fine. I guess I can solve this. The same way for this one also. It is DP. Finish this. Close this. And also this one, and remove this. Okay. And also, yep, yeah, we can return like this. If like you can return like this, if dp of array dot length length minus 1 untarget is equal to 1, return true, or else return false. I hope this will work. Let me try. This one is pass. Oh, sorry, I thought it was pass. Okay, it was boolean. Okay, it was boolean. You're passing. Okay, that's nice. That's nice. If this is equal to 1, if this is equal to 1, push true, else false. Let me try. Where's the error coming? If target is greater than or equal to if it is equal to 1, same way, true, or else false. False. Got it. Case 1 failed as expected. Why it will become true? Okay, let's ask ChatGPT. Where did I have mistake, bro? I hope it was correct. There's a couple of logic and indexing error. Loop index. Okay. Yeah, its sum is greater than. Okay, that's correct. Similarly, you use a target instead of sum in several places. Okay. Mm, okay, but you are assuming that area of 0 is less than r, but you don't check it before. Uh, First solve these issues. First, uh, instead of target, let put sum, right? Sum. Sum. Mm. Not there. Is that the issues first thing I have to solve? Mhm. I mean, for true or false, why we need to store this also? Yeah, that's common sense, right? Yeah, definitely. If it's false, it will. I don't even have a common sense, I guess. Chill, chill. Bot. Let me call myself a bot. Noob. Comment on noob. I'm just kidding. Okay. These are the things. Okay, this is the condition. Okay, got it. Initialize the first element as 1. That's what we did. I mean, let's try and run it. I mean, this one also. Why I'm stressing a lot? I don't want to this. I don't want this. I don't want this. This one. No, I just return it and there. That's it. Let me guess, it will run. It will run. Okay, sorry. It will run. Yeah, it will run. Let's check. Queuing. Let's pass all the cases, bro. Index out of bond. Index 7. Why it is happening? Yeah, 1, 2, array dot length, sum is less than or equal to target, sum plus sum is greater than dp. One second. You have to do this if this is the condition. I mean, I heard that this is the condition that you will always miss, but I don't get it. Let me try this. Target, how can be the target? Yeah, sum, it could be some. I mean, initialize the first element. Okay. You can take that. That's it. Okay. Please don't fail. चल रहा है. Okay. Don't forget, friends. This is the key here. If and only if array of 0 is less than or equal to target, then only fix it. What was there? I mean, okay, if you miss it, what? I mean, it can't. I mean, okay, got it. Okay. It has to be less than target, it's fine. Okay. Okay. Whatever be the number you have to push. If it's 4 or 5 or 6 or 7, you're making it as a target, right? You don't exactly think. Don't think too much in the tabulation, okay? It's always confuse you. It's better to leave it when the thing is completed. That's it. Okay. Okay, partition. I mean, I guess it only takes so much time, I guess. Yeah. This is the excellent sum. Let me tell you, it's too easy. One of my TCS interview got this question. I mean, not in this way, but with this mindset, I solve this problem so that I can relate it to that. I don't remember the problem, but what I think of is in this way only. The question was asked like some, can you divide even numbers and odd numbers? I mean, I don't get it. Into two averages or something like that. Not even and odd. Can you divide an array into two different averages? Something like this. Okay. I don't remember the question exactly, but these type of question was framed. But with this concept, you can solve that question very easily. Okay, let's do this. Given an integer array nums and return true if you can partition array into two subsets such that sum of an element both sets are equal or false otherwise. Can you divide these into two sets 1, 5, 5, 11 and another set is 11 so that you can divide it, right? That's what they're thinking. Think about an approach like it's a continuation of previous problem. I'll give think about this solution. Try to get the solution. I'm giving you the hint also. It's an extension of the first problem that we did. Basically, okay, pause the video and think and continue the video, but I can't wait, right? What the logic was, let's say what I will do is here what the table is storing. I mean, let's talk about the tabulation. Okay, what's the tabulation doing? It stores the target of an element, right? It shows the target of an element. 1 second. Just sum divided by 2. Yeah, it's too easy. It's too easy. Can you get the sum by 2 by, I mean, let's say the total sum is, let's say here 22. If I get the subset of 11, then I can definitely get it, right? Then the other sum must be an half of it. That's exactly true, right? That's why I'm passing the here. We are just passing the target as sum by 2. That's it. It's the next question. Partition set into two sets. This is the hard question. Sorry. I thought these two. Sorry, I confused it with the question. Yeah. You need to partition into two arrays of N to minimize the absolute difference of the sum of arrays. To partial nums, put an element of a nums into one of the two arrays. Return the minimum possible absolute difference. Return the minimum possible absolute difference. Okay, got it. Okay. You need to partition the array into an how many subsets? Partition nums into an two arrays of length n to minimize the absolute difference. Okay, got it. Okay, they should be equal. No need to be equal. I mean that minimize the absolute sum. Yeah, no need to be an equal. The partition nums put each element of nums into an one of n. Here the tabulation comes in. What's the tabulation saying? I mean, for tabulation, what you can say is, you're saying, let's go to tab and see what's the tabulation can say. Let me tell you what the tabulation can say. That's nice. I thought everyone can see my password. Okay, that's nice. I didn't expect. Okay, what's the tabulation can do means, let's say here there is an array called 334. Let's take another small array so that I can explain it so easily. 147 1457, let's say. Let's take an target of 8, I guess. Okay, what's tabulation can do means, we are getting a 2D array, right? Like which contains an array of dot length 4 rows and 8 columns. Yes, 8 columns. 4 rows and 8 columns. Index 0, index 0, index 1, index 2, for index 3. Target 0, target 1, target 2, target 3, target 4, target 5, target 6, target 7, and then 8. I mean, here you can go from, I can go from 0 also. No need to worry. That's why you are taking target plus 1. So that what it was doing means, let's say here, let's say an index 0, right? Index 0 means this one. Let's consider this. Can I get a sum of 0? No. False. Can I get a sum of 1? Yeah, you can. True. It false. Can I get a sum of 2? No. False. Like that it goes false. Okay. Till index 1, 2, 4. Okay, this is what you are doing. Okay, by somehow, like, you can pick or not pick, do whatever the thing you want. Can I get a 0? Yeah, maybe you can write true, because taking a null set, you can here also you can write true. Let's show those go. Next, for 1, yeah, you can get 1 till that by not picking this. Can I get 2? No. False. Can I get 3? No. False. Can I get 4? Yes. True. Can I get 5? True. Yeah, remaining all are false. Yeah, why don't iterate it? Okay, let's say, and the other one is 145. Okay, 145. Can I get 1? Yeah, true. Can I get 3? False. True. False, like that. 1 4 5 7 states that thing only. Same way you'll fill it till the index 4 whether you can get the sum or not. Okay, now you can ask this array, I mean from this last row you can say that what are the possible numbers that you can generate from that array, different sums. Let's say 0 1 2 3 4 5 6 7 8. Is the target 8? No, right, 9. What do you imagine earlier? 8 only, right? Yeah, it's 8 only. Can I get 0? What's the total sum of this? I mean, think in this way. I want the minimum sum, right? Let's think about in this way. I want the minimum sum. What they're asking, that if you take two subsets like this one and this one as two subsets, the difference should be minimum. Are these two, are this one and this one, and this one and this one. The difference should be minimum. Okay, I mean, I can't divide all the subsets. I can't generate, the brute force is generate all the subsets and do the subtraction between every two alternates by putting math.abs or whatever. Find the minimum out of this. That's so lengthy process. But from DP, what do you know? From the tabulation table, you know from 0 to target 8 which number is produced, which number can be produced. These all numbers are produced or not by taking 1 or 2 or 3 or 4 indexes. It doesn't matter, right? Is getting an from by 4 this, can I get in 0? True. Can I get in 1? True. Can I get in 2? False. Can I get in 3? False. Can I get in 4? True. True. Can I get in 6? Yeah, true. Can I get in 7? False. Can I get in 8? Definitely true. This is the till our target only, right? No. Why I'm going till target? Why I'm going till target? No, target is very bad. Hey, no, sorry. How I'm getting? I mean, that's the tabulation table for the target, right? Okay, what we will do here? Let's give the total sum, I guess. It's better to give total sum. Yeah, it's better to give total sum, I guess. Yeah, it's better to give total sum. Yeah, this question was not able to. I mean, I tried so many times, but they're failing. This one is the approach because generally it contains a negative number, so that's why it failed. No need to worry that much. But the thing was, the approach was in this way only. Yeah, you generated a DP table. How much sum you are thinking? Yeah, the sum of all elements. Yeah, think about the sum of all elements, like how much I get? 12, 16, 17. Till 17, how many numbers? Then you have to choose smaller number. Like that, let's say all the possible true or false you can write. Let me tell you how it works. If I take the subset of one subset size is 0, the total sum, definitely the remaining subset size is 17 minus 0, which is 17. The absolute difference between them is 17. If I get this one as 15, the absolute difference between them is 15, right? And can I generate this subset? No. With this possible, not with this not possible. Yeah, for one it is 4. The remaining subsets is 157. 157 means it is 13. The difference is 9, like that. It is also possible. The difference is 12 minus 5, right? It is 12. 12 minus 5 is 7, like this. It is also possible. 11, which is nothing but 6, 5. Okay. And next one is not possible. For 8 it was possible, but it goes increasing. For whatever till get 8, and it goes in the reverse way only, because if I'm getting 9, let's say here I'm get 9, right? Definitely 9. The difference is 1. Here also I'm getting is false. Okay, 9. Definitely from, let's say next one is 9. 9 is possible, yeah. Then definitely it is 8. The reverse are swapping. The answer is 1 only. For this, the minimum difference that we can get is 1 by dividing what? 8 and 9. 8 means 7 and 1, 5 and 4. This is the combination that you can do. Without tab I decided. No, check once. Sorry. What I tell was simple. These are the elements from, we know that where these are the possible elements of sum, right? 0, 1, 2, 3 and till 17 the sum. You check whether it is true or false by DP table. Let's say one subset is 0. What is the other subset? Sum minus this one, we'll get 17. Then 17 minus 0. This is subsets, one subset sum. This is another subset sum. We need difference, which is you get 17. Then if one subset sum is 1, the remaining subset must be 16, right? It's 15. For 2, the subset is not possible. It's not possible. For 4, yeah, it is 4. Then the remaining 5, 7 and 8, 12, 13. It's 13. The difference is 9. For 12, it is 7. It's 5. For coming to 8, let's say the difference is 9. We will get 1. For, let's say, these half elements, after that it repeats. Like here comes 9, then 8. Then it's like goes by. Here, let's say, next comes like 11 and 6, like that. That's the thing. So that 1 is the minimum difference here. I hope you guys get it. For these, generally what happens means they said they given the minimum negative values also. That's the thing that fails here. You have to think in another data structures, because arrays can't store the negative indexes, right? That's where it fails. But you can use hash map, but I don't know why this problem is not working. I tried so many times. That's the problem with the remember one thing, count means nothing will be changed. Let's say count number of subsets, like same thing, everything is same. Instead of return if index equal to 0, return, yeah, same thing, return 1 if array of 0 is equal to the target that we need, return 1 or else 0. Okay, if index is less than 0, return 0. We don't need this. That's the thing. When sum equal to 0, return 1. That's it. So that return pick plus not pick. Other than this, nothing will be changed. count, you need count, right? Do you want to see the code? Submissions. Okay, I didn't submit it. Let's see the editorial. Expected approach, memorization. Yeah, it's simple. Let's see this one only, so that we can write it right. Why they are making so much complicated this one? Yeah, okay, they are doing the same thing but using the modulo. I mean, the upside downs is a little bit confusing, that's it. Why they are not adding? What's the problem? Question is count the number of subsets, that's it, right? And like count the partition within given difference. Let the sum of two elements are sum1 and sum2 given the difference. Count the number of partition in with sum1. Okay, let's think this problem. Okay, got it. The only one problem, I didn't get it. The difference should be 3. The difference should be 3. Like, you can do like all the things and check whether the difference of some, like we did it in this way, like you get it right. And check whether the 3 can be possible or not. That's it. I think that's the best solution. The subset difference. You got the minimum out of this. Can't we find the 3 for which possible case? That's the way to do this question. Let's see the solution. No, I'm sorry. Did I miss the question? Did I miss any question? I mean, count the number of partition in which sum1 is greater than or equal to sum2 and the difference between them is equal to d. Okay. And let's say, okay. Yeah. I mean, I didn't. Let me think in this way. Let's think in this way. Sum1, can you tell sum1 plus sum2 is equal to the total sum? Let's do some math. Total sum of array. Yeah, you can say that, right? And they are saying sum1 minus sum2 is equal to d. Let's find that. You know d, you know total sum. Let's eliminate one variable so that it's better, right? Let's add it to sum1 total sum plus d, sum1 equal to total sum divided by 2. This is the case. You need to find this target. If I get this, then the difference between them is definitely D only. That's it. Got it? Yeah, got it. I wanted the count. Assign cookies. This is some basically greedy problem. We can solve it there. This is too easy also. Don't worry. Minimum coins. This one also same, but light modification. Let's give me a second. Like coin change. You are given an integer of coins and an amount, and return the total amount of energy. Return the fewest number of coins that you need to make up that amount. If the amount of money cannot be made by any combination of coins, return -1. Okay. I mean, here you have an infinite supply of coins. You can choose 5 as many as times. In previous problems, you can choose only one, so that you'll pick it and move it to another index. What here, like check here, there is no. This is also indicated. I mean, they're also same, but I'm trying to relate it. That's here. You cannot move index. I mean, it's like a logic. You can stay there. What it will do means, for every index, let's say, recursion is too simple, man. Once you get the logic, like 1 to 5 is the coins, right? You can stay here as long as one is staying. Every node has two things, two persons. What they say is, I will stay. Second one, I don't stay, man. I will move. This one is also have to. It will move to here, but these two are not same. Try to remember it. Everything has to. This is a visitor, which has a relation which comes with an 2 only. I hope get it. Let's say 5 has an 2 issues. One is pick, not pick. So that pick also, I will stay at that index only. By not picking, I will move to the index -1. Index -1. By picking, what I am doing, I am removing the target. This is a non-pick case, right? For non-pick also you have to. For non-pick also you have to. For this 5 also you have another 2. You can move to the index -1, or you can stay there only. It's basically like I have an 11. Initially, for this case, what I am doing, I did -1. Okay. What it becomes 6. Okay, got it. For this case, it becomes still 11 only. For this, the sum becomes 6. So that for 6 I can move to 2, this one, or I can stay with 5 only. Everything has in 2 cases here. Everything has in 2 cases. But one will go from to the, I mean, like how can I say, I'm trying to tell you something but I'm not able to form it. Like this has 2, this also have 2. This has an authority to go from here to here. For this, it has an authority to move on the left side. For this also it has 2, but we are restricting it with base case. It has to some base, right? Otherwise it has to go negative. How much it will go? Got it? I mean, we have to bound it. That's it. That's it. You'll get it. You'll get it after. Okay, that's it. Coin exchange. Uh, Target sum. It's, hmm. It is also too easy, man. I mean, you are given an integer of an array and a target. You want to build an expression out of nums by adding plus and minus before each number and then concatenate this. Oh my god. Oh my god. Yeah, I wrote something like this. I don't know when I wrote this, but you should ask the interviewer whether the array contains zeros or not. Okay. If the array contains zeros, then it may be a different case, like 101. How many target sums can be formed by some? There are so many. Mm, just give me a second. Let's relax for some time. Okay. You have to have assign signs like this. But think in this way. What the thing you are doing? You're separating. Let's take minus common out of this. You are adding 4 ones. You are adding 4 ones and subtracting. What about this? You are adding like same way. Same way this is possible. Here also the subset sum difference between the two subset sum can be 3 or not. That's it. Sum 1 minus sum 2, 3. How many subsets is possible? That's it. So that we defined our formula, right? So formula here, this one is this one can do the issue, right? Okay. Y minus, should I get? Array contains zeros. Let's allow the index comes till 0. We don't pick anything because we wrote if the condition before pick. Okay. You are writing in condition to not pick, right? But I'm sorry, I forgot this. Like, how can this becomes plus, right? It's some plus target by 2. Some plus target by 2 is the target one. I hope that's the thing. like target 2 they are finding or something like that. Both has to be same, right? Both has to be same. Did I miss something like? uh, why do some just give me a second. Yeah, it's minus, sorry. We are subtracting it. Yeah, you can find anything, I guess it will work. It will work definitely. Let's try this. I don't know. It has to work, I guess. Yeah, it's working. It is working, bro. If nums of array contains 0, target 0, then what? If index, let's write in base condition. If array contains only one element, total length will be nums total length minus 1. 0, you're passing index equal to 0. If index equal to 0, target equal to 0, okay, now return 2, expected 2, it has to be written 2, right? Target 0 and nums of 0 equal to 0. Why it is returning 1? Target 0 or nums of 0 equal to target. Okay, it has to first execute the first block, right? It is passing and it has to be returned. Why it is executing first? I don't know. Output 1. Why like that? Error. I don't know why it is returning 2, or it has to return 2, right? Expected 2 first, if case has to be execute. Why second is executing? Should we write the base case something like that? If like sum becomes whatever you gave, sum equal to, okay, is basically written from this statement. Why these unnecessary blocks? Why these unnecessary blocks? I mean, it has to pass. Why these unnecessary conditions? I know the code has to be executed before recursion, but these things makes code like edge cases more complex. Coin change. This is also same problem, but the thing was like there are 4 ways to make that amount. Like you don't in previous problem what you did, like how many what you written, like how many coins do we need, right? How many coins, first number of coins to make that amount. Now what means you have an infinite supply. It's not a first coin, actually how many coins with different ways. I mean the amount 5, how many ways you can print it. This is an 5, one way. By taking these 2 times and this 1 time, by taking these 5 times, by taking these 2 and these 3 times, like that. It's basically you can do in 4 times, right? Okay. What you're doing, like you got the math.min every time. Here you will get the you will return take plus not. That's it. Yeah, you can go till index. I mean, you don't need to make an coins of index of it. If index equal to 0, if amount becomes 0, whatever it is, it will become 1, right? Here what I did, submission, let me check it. You don't need this, in that case also 1 plus, yeah. A math.min of take comma not take, that's it. Unbound knapsack and these 2 are also same. You can check this. Rod cutting problem, this one also same. You can check this. Yeah. We'll continue the stream tomorrow. Let me record the video so that I can send you in a more clear way.